Fundamentals of cloud computing. Before we dive head on into cloud security, let's take a brief look back at how we've reached here. Knowing the history of cloud computing gives us a much better appreciation of the technology and how cloud and cloud security has evolved over the years. If we take a few steps back, then the last couple of years have been crazy if you're in the cloud industry like I am. Cloud adoption shot through the roof when the global pandemic hit, and companies suddenly realized that relying on on-prem infrastructure and private data centers might not be the most sustainable model in the world. Digital transformations and workload migrations became daily buzzwords as companies wanted to transition to the cloud as soon as possible, which is not always the best idea. Cloud is like any other technology and requires a proper business justification and strategy for a company to truly see its benefits. Most cloud migration failures I've seen over the years happen because of not having a proper cost-benefit analysis and business driver for cloud adoption. So let us take a step back and look at what cloud computing is and how it works at a very high level. There was once a time when all companies used data centers that they owned or co-owned. This could be in the form of a massive dedicated data center or a simple server closet. But this is where you kept all your servers supporting your business, email, etc. This also meant that companies maintained all the IT infrastructure needed to run their business on site, along with the costs associated with it, such as personnel and hardware. This was by no means a cheap model with costs like hardware upgrades, uninterruptible power supplies or UPS, cabling, disaster recovery sites, staff, etc., making CIOs feel the annual pinch in their budgets. Along with the operational overhead, there were also the certifications and assurances that most companies need to comply with, like ISO 27001, PCI DSS, etc. The next evolution was data center virtualization, which enabled IT teams to logically create virtual servers from traditional physical servers, resulting in more efficient usage of existing hardware. This was accomplished using software referred to as a hypervisor, which effectively abstracted the hardware from the software and enabled us to literally divide a physical server into multiple virtual servers. While this seems and was a great innovative step forward, the problem remained that all of the physical hardware was still being kept in the company's data centers. The hardware was being more efficiently used, but a lot of the cost and overhead were still present for CIOs. Thus, the concept of moving the entire data center outside a company's premises was born, and cloud computing started to take off. Some have argued that cloud computing pretty much started with the internet, given the logic that Yahoo and Hotmail were cloud services. However, most people associate cloud computing with hosting of infrastructure, so that is what I'll focus on here. Cloud computing does not mean that your data is floating somewhere in the cloud or space, but simply that you do not have to worry about the hassle of maintaining data centers, networking, hardware, and so on. And all of these things get abstracted away from you and moved to the cloud service provider. You pay for the usage of the resources on the cloud and move to a metered model like electricity or water, in which you pay what you consume. More on that later. So, what cloud computing traditionally refers to is storing and accessing data, applications, or services over the internet, i.e., the cloud, instead of in physical servers or storage on your data center. There are other models also, which we will discuss, but this is the standard meaning of cloud computing, which most people mean when they're referring to the cloud. Due to cloud computing, customers can access their data or services at any time, regardless of where they are located. The benefits of the cloud are obvious, as customers no longer need to worry about hardware, operational overhead costs, staffing, etc. And this enables them to accelerate digital transformations and launch products into the market. Organizations can move faster since they don't have to purchase and provision hardware, and everything is software defined. Reduces downtime thanks to inherent elasticity and other cloud characteristics. Saves money due to reduced capital expenses and better demand and capacity matching. And it's more secure since cloud providers have significant economic incentives to protect customers. So what makes the cloud unique? Well, based on industry definitions, there are certain specific characteristics of the cloud which make it different from traditional on-prem infrastructure. Resource pooling. Easily the most fundamental characteristic of the cloud is resource pooling, meaning the provider abstracts the physical layer away from the customer and collects resources into a pool. Portions of this pool are then allocated to different customers and adjusted based on their needs or policies in a completely transparent way, i.e., you as a customer don't see or care how many actual physical servers in a data center your services are consuming. Self-service. The cloud does away with the physical provisioning of infrastructure and enables the deployment of IT resources, usually with a button click. If the IT team is required to add or remove platforms or infrastructure, then they can make these changes almost instantly. In some cases, provisioning of infrastructure can even be moved to the end user, removing the need for IT to be contacted, making it a fully self-service model as you no longer must wait for weeks or even months for infrastructure to be provisioned. Note: this might not be the best thing to do in production environments, though, as misconfigurations are some of the biggest reasons for cloud data breaches. Broad network access. The cloud, by its nature, is accessible from anywhere, in most cases, via the internet. Your business can be situated anywhere across the world with multiple branches, and you don't need to provision costly connectivity to a data center. If you have internet connectivity, you'll be able to access your applications, servers, and platforms from any location, which can be a game changer for corporations struggling with access issues. If the pandemic has taught us anything, it's that remote working and work from home is here to stay, and cloud computing is one of the easiest ways to enable it. Note: of course, this does give rise to risks such as increased attack surface, data residency issues, and reliance on the cloud provider, which is where cloud security comes in. Rapid elasticity. In traditional environments, you had a big problem if you underscoped the infrastructure needed for a project and the application demands were more than projected. Similarly, if it was overscoped and the application did not meet its targets, then it resulted in sunk cost. The cloud gives customers the ability to scale their infrastructure at will, giving them a great deal of confidence when designing new products. Storage or computing power can be added dynamically if the load increases and then removed once it subsides, often referred to as auto-scaling. Note: this elasticity is not without its risks, though, as customers need to monitor it as if the environment is scaled up to meet demand, but left in such a way that customers will face a nasty shock at the time of billing. Usually, alarms or alerts are set up that can dynamically scale up and scale down the infrastructure with thresholds set. Measured pay per use. The cloud enables a pay for what you use model, like utilities, like electricity or water, and can result in financial savings if the cloud model was properly understood. The usage of resources can be closely monitored by the customer, and this enables more predictable billing and moves customers from a CAPEX to an OPEX style of budgeting. This is unlike the on-prem model where you must buy storage or hardware and then replace them after 3 years or 5 years when they're no longer able to meet the requirements. Note: these benefits, while very much possible, only materialize if companies understand the cloud model and re-engineer their applications to take advantage of it. Simply copy and pasting an application onto the cloud usually doesn't result in benefits and might increase costs in some cases. Summary: we quickly covered the cloud and its brief history, how the cloud has evolved into this current state, and what makes the cloud unique. It's imperative to note that cost savings when using the cloud is directly related to your know-how in using it. Each cloud platform has a lot of buttons, knobs, and switches to help you measure and monitor your cloud usage to be appropriate to your needs. But they're trying to run a business too. They want you to use it, and they might even want you to save a little bit of money, but they won't manage your usage for you.